Hello mga palangka, kumitag.
The Bluetooth device is ready to pair.
Okay, how are you mga palangka? Okay, welcome back to my YT channel. This is again a singer internal voice. Oh my god. Look at my hair. Oh, what's happening to my hair? Okay, so it's gonna be a beautiful Saturday. So it's gonna start our vlog with, a little bit of. This time I'm gonna touch a little bit of physics. Actually, it's also related to chemistry, but this topic is more on physics if you try to go on details. Okay, so it's gonna be like we need to understand about forces. Forces are discussed well in physics, right? Forces. Okay, so forces, motion, forces, speed, velocity, acceleration, like that, because this is more on the energy related, topics. Because physics is a branch of science that deals with the study of matter and energy. Okay? Chemistry will just be connected there a little bit because of matter. Okay? Liquid, solid, and gas. Okay? So how it behaves through motion, speed, acceleration, something like that, then it's covered by physics. But the first part of physics, guys, is more on the velocity, speed, like that, blah blah blah. Okay, distance, displacement. So more on the objects. It's not really more on the substances. Okay, you got what I mean? So that's really the clear identification between chemistry and physics. You cannot expect their chemical reactions. Always objects, objects, objects like that. Motion, 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 speed, speed, like that. Okay? So there's no such complexity if we study about physics, because most of the study of physics are highly measurable. Meaning to say, we can really quantify, we can really imagine, and we can see things around us, because it's not deeper compared to chemistry that we need to study the molecules, the ions, in which we cannot see by our eyes. Okay, this is also make physics more interesting, because we can see, we can touch, okay, and we can imagine that's going to be happening in the actual scenarios, something like that. Okay, like this topic. Okay, I think this topic is the favorite of um, electrical related profession, okay, especially the electricians and electrical engineers. Okay, the this is related to electricity, but we don't focus on electricity in motion. Do you know what I mean? Electricity in motion, meaning we don't cover here the electrons flow that much. We don't cater here the Ohm's law that much. Okay, Ohm's law is equal to the voltage times the current times resistance, right? Is this correct? Is this correct? This, because I forgot. This is the Ohm's law, right? Okay. So in our discussion for this, though this is really related, also related to the practical electricity or the Ohm's law, then we need not to touch this much, because we are dealing with electrostatic forces. Okay, electrostatic forces. Okay, like that. So our topic for today, chart, is electrostatic forces. Okay, mga palangga. So, what is an electrostatic forces? Okay, these are forces as a result of the electric charge at rest. Okay, these are the forces as a result of electric charges at rest, meaning static. It's not moving. As I told you, we're not focusing on the electrons flow. Okay, we are focusing on the electric charges at rest. So electrostatic forces. So in relation to the matter. Okay? Get the point mga palangga. I cannot state the objects. Okay? I would rather go to the matter. Okay? Okay, for example, guys, I have again, I have calcium chloride, right? calcium chloride, something like that. It's gonna be the chemical formula. Let's go directly to the perfect chemical formula. We don't need to teach you how to do the formula because we've done that before, right? It's gonna be calcium chloride. It's gonna be like this, okay? Then if you try to dissociate that with water, okay, say for example, it will become calcium positive 2 and chloride negative. Okay? Ganon. So, the positive 2 here will be your cation. Okay, cation. And the negative 1 here is your anion. Okay, so these are ions. Positively charged ions and negatively charged ions. Or we can say also positively charged particle or negatively charged particle and ion. Now, this cation and ion is what we know as the electrostatic forces by their charges, in terms of their charges. So we can develop electrostatic forces, okay, through their electric charge at rest. Okay, electrostatic forces. Okay, why? Because of their electric charges. Okay, electric charge of cation is positive 2. Okay, we relate this to electrostatic. That's why we put electrostatic charge as our adjective. Okay, you have to put electrostatic charge or electric charge. It's just the same here because they are not moving. Okay, something like that. And then negative 1 is our electrostatic charge also. Okay, like that. So if you add the electrostatic charge of positive 2 and electrostatic charge of negative 1 or the cation and an ion, it will result to a net electric charge. Net electric charge. So net electric charge will be also your net electrostatic charge. Okay, it's just the same. Okay. Now, because of your electrostatic forces driven by this ionic dissociation, calcium positive 2 and chlorine negative 1. So there's an electrostatic forces. Now, the electrostatic force of calcium positive 2 will be directed toward chlorine. So let's denote that as an EF. Okay, EF, let's say calcium, right? Subscript, small letter C, A, calcium. And then we have also the electrostatic forces directed towards calcium. Okay, so they are opposite with each other. Okay, electrostatic forces of an ion, something like that. Okay, when we add that to electrostatic forces of calcium plus electrostatic forces of an ion must be equal to 0 because this is not moving, stagnant or static. Okay, that's why we have electrostatic because your calcium ion and chloride ion are not moving when they are combined with each other, so electrostatic forces. Okay, so your net electric charge or your net electrostatic charge will be equal to 0. Okay, right? So we will say positive 2. Okay, like that, plus negative 1 must be equal to 0. Okay? You get the point? Now, since this is negative 1 and this is positive 2, you need to undergo dissociation reaction in order for the charges or electric charges or electrostatic charges to be balanced. Okay, because if you subtract positive 2 and negative 1 is not equal to 0, it's equal to positive 1. And it's not a 0 net electric charge. So you need to do the dissociation. Okay? Something like this. Calcium, ganun, juba chuchu, ganun. Chloride is equal to calcium positive 2, okay, plus chloride negative 2. Now, how can you do that? If the electrostatic charges or electric charges driven by electrostatic forces is not yet balanced because your objective is to get a net electric charge which is equal to 0. That's why we need to have the dissociation chemical reaction. So in short, guys, we are dealing with here electrochemistry. Okay? Meaning, we produce electricity through chemical reaction, which is specifically chemistry of dissociation of chemicals, starting from calcium chloride, and it will dissociate to calcium positive 2 plus chloride negative. Okay, now we need to balance because we cannot have a net electric charge equal to zero driven by your electrostatic forces if your electric charges are not equal in figure. You know figure or magnitude? No, magnitude? Yes, the value. Okay, like that. So positive 2 cation and negative 1 chloride, if you subtract, you will produce 0. So in order to be balanced, neutralized, or polarized, because basically this is highly polar because opposite charge na talaga siya, then it should be 0. So we need to balance. Okay? So the step is to balance in terms of atoms and in terms of charges as well. Okay. Now, chlorine gas 2, ganon, calcium 2. Okay. Now, if we have positive 2 here, during the dissociation reaction, the chloride will have a charge of negative 2 because this is negative 1 times 2. So this is negative 2 na ang charge during dissociation. Because our objective, we can get a net electric charge of 0, then this is not balanced yet. And we need to change the negative 1 to negative 2 so that it will become positive 2 minus negative 2 is equal to 0. So perfect. This will be your electrostatic net electric charge driven by your electrostatic force. So we need to do the dissociation chemical reaction. You get the point? Because naturally calcium positive 2 and chloride is not balanced in their electric charges. But if you add sodium and chlorine, sodium chloride, it would be no need to dissociate in this way because they are both the same charge. Though we need also to dissociate, but immediately we can say it is balanced, the electrostatic charges or electric charges, because positive 1, sodium, negative 1, the chloride, then bingo, 0 net electric charge. Okay? But in here, we could not expect, because calcium having a positive 2 charge, and then, guys, belong to the group 2A, which is an alkaline earth metals. Something like that. Okay? Good point mga pala. So this is electrostatic forces. Ganon. Okay. So I need also to, to define the forces involved here. Okay? Erase. Right? Okay. If we need to balance the charges here, chemical reaction. So calcium chloride, normally neutral compound. So charge is 0. So 0 times coefficient 1 is equal to 0. It's equals to calcium positive 2 times 1, like that. And then chloride negative 1 times 2. Then 0, 2, okay, minus 2, then balance. 0 is equals to 0. Okay? If you dissociate calcium chloride into water into aqueous solution. So perfectly balance the electrostatic charges. Okay? So this is very important, electrostatic forces through their difference, okay, of their electric charges, and we can have a 0 net electric charge. So if this gonna be happening, mga palangga, so we have now an ionic dissociation. The process is ionic dissociation from calcium chloride. Now, this calcium chloride is basically an ionic compound. Okay? Ionic compound because this is driven through ionization. Okay? Releasing cations and ions through the difference of their electric charges, an ion and an cation, driven by electrostatic forces directed toward each other. And I thank you. Any questions so far for this topic? Before I will give you sample problems. Okay. But, if we try to connect this with the columns below, we can do that also. Okay? So, this topic really is, ang daming pinaghuhugutan itong topic na ito because we need to relate that to the Coulomb's law and the Faraday's law also, Michael Faraday of electromagnetism and electrochemistry. Okay? So it's gonna be like that. These are the scientists played great contribution in electrochemistry and electrical energy. Okay, something like that. Mr. Michael Faraday and Mr. Augustine Columns in 17th century. Correct me if I'm wrong, huh? Okay, it's gonna be like that. Okay. Now, before touching that, what is the title of my vlog? I include, what's that guys? Formal charge? Yeah. What is the difference between formal charge and a nuclear charge? Okay. Nuclear charge is basically directed, toward the nucleus. That's why nuclear charge. So it's gonna be the proton and the neutron. Okay, nuclear charge. And also the electrons. Okay? More on the nuclear or the nucleus. That's why nuclear charge. And the formal charge is driven to the chemical bonding, the Lewis dot structures. The G.N. Lewis is a scientist, played a great contribution in the chemical bonding so that we can determine the compounds whether it is non-polar or polar. Okay, you get the point? So that is Lewis dot structure. And then in that, we need to compute for the formal charge of each element bonded to the central atom of that compound. So that's the difference. Okay, get the point? So basically, you cannot extract directly by just looking the element or the compound when you obtain the formal charge. To the point, you need still have to do the chemical bonding. Okay? And you need to account the valence electrons in the outermost shell of each element of that particular compound. Something like, for example, formal charge. We need to compute this one. For example, if I have a compound, let's say, sorry, I have sucrose, right? Sucrose is a refined sugar, the white sugar, like that, okay? Or the table sugar that we have in our kitchen. Okay? Sucrose is 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. This is a disaccharide sugar. Okay, belong to the carbohydrate family. Okay, with the point. So it's gonna be like carbon 12, H22O11. Okay, one shot. How can I get the formal charge for this? Okay, so you need to get the central atom for this, the carbon. You need to bond like this. You get the point? So maglinis that structure ka, get the carbon in the central atom and how it bond to hydrogen and oxygen. So, sobrang mahaba ito because we have 12 atoms of carbon. We have to get the 12 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ganon. Diba? And then, hydrogen. Connect that here. And oxygen also connect that there. Here. Okay, you get the point? So, there are 11 atoms of oxygen. So, yung i-connect ang mga H there, alam mo, ganon. Okay? Like that. Okay? Like that, like that, like that, like that. Until you will finish, you can obtain 22 atoms of hydrogen and 12 of carbon and 11 atoms of oxygen. Something like that. And you can formulate the formal charge. So, ano din mo guys? Ang formula sa formal charge, mga palangga, take note. Okay? We will not go in detail in organic chemistry because our topic is actually physics and we go with chemistry again, right? Like that. So, formal charge is equal to the valence electrons in the outermost shell, ganon, plus the number of bands, how it banded. So, we don't have to state examples too long also, no? So, we go to the most brief example that we can easily write. So, it's a methane. Okay? Parang dali na siya, di ba? Because sugar, my whiteboard is very small. There are 12 atoms of carbon and 24 atoms of oxygen. Oh my gosh! Right? So it will take another time. But just follow the same pattern if you want really to get the formal charge of sucrose. Okay? Like that. So cross glucose, dextrose, mga ganon. Mga ribose, whatever. Okay? So, valence electrons plus the number of bands, mga palangga ulitan. Okay? Number of bands. B-O-N-D. Okay? Number of bands. Okay? Then, plus the unshared electrons. Okay? So, klaro kayo mga palangga, that you will do the Lewis gas structures chemical bonding if you obtain the formal charge. For example, you don't do that. Your instructor will say, what is the formal charge of beryllium? You can never answer easily because you need to still do the chemical bonding. You get the point? Okay? Like that, if you just look, there are 7 electrons in the outermost shell. O ganon. So, troubleshoot if you're just looking about extract if you're trying to look directly to the periodic table. But the formal charge, dili gayon. Okay? You need to do the chemical bonding first, Lewis gas structure first, so that you can determine the electrons shared and unshared, how many bonds, chemical bonds, the single band, the double bond, and the triple bond, something like that. Okay? So, a little bit mention of ano pala, organic chemistry, right? If you understand about formal charges, okay? Because these bonds, chuba, are discussed in organic chemistry in the introductory part. Single bond, double bond, triple bond. Okay, as well as the formula of, the single band, formula of the double band, formula of the triple band. But we will never touch there. Okay, let's, for example, CH4, mga palangga. Okay, like this. Okay, you need to do the Lewis structure for the purpose of brief discussion. So, 4 electrons in the outermost shell of carbon. 4 hydrogen, like this. 4 hydrogen. So, completely shared. So, this is non-polar covalent bond. Wow. Non-polar molecular covalent bond. So, if it is a non-polar, then calculate the formal charge. Okay? Carbon, you need to do separately and then add later on. Okay, carbon, 4. Number of bands, klaro kayo, 1, 2, 3, 4, 4. Plus unshared electrons, nothing. Right? Because this is non-polar. Then nothing. Okay? Like this. Nothing. So 4, number of bonds. So we have a formal charge of 8, because we have the valence electrons of 4, and we have the number of bonds of 4, and then unshared, wala man siya, 0. Okay, this is for carbon. And now for hydrogen, mga palangga kumitag, valence electrons is 1, plus number of bonds for hydrogen, still the same because they share the same chuba-chucho in the chemical bonding. So 4. Okay, no unshared also. So hydrogen is equals to 1 plus 4 is equals to 5. Ganon. So your total charge is 13. Formal charge is 13, something like that. You get the point, mga palangga? So it's not the same with the nuclear charge. Right? Okay. You get the point, mga palangga? Muna siya. Okay? Okay. You could not expect a perfect 0 in our covalent bonding because this is not ionic, ha? Okay, ionic, it always results to 0 siya talaga. Net electric charge is what I discussed a while ago. Any questions so far for the electrostatic forces and the formal charge? What is the other one I put on my description? Guys, I forgot. Sorry. Okay, thank you so much. And you can comment down below in the comment section. You can like and you can share also. You can subscribe to the channel if you like, and then click the notification bell for some news after some singer, eternal voice. Welcome back later on for some more problems of electrostatic forces computation. Thank you so much. Bye-bye, everybody.